All right, guys. Good afternoon. How we doing? I finally have my stuff, so I can actually make a few videos here. So what I'm going to do is I'm going to assign the same exact type of problems that I did last class, um, and I'm actually going to go over just a couple slides of notes, and then I'm going to actually go over the homework problems. I'll go over like 3 or 4 of them to make sure that you understand them. Um, and then we'll kind of go from there. On Wednesday, we're going to do the second part of 2.6. And then Friday, hopefully I'm back. We will see uh, how I'm feeling because Lord knows I don't want to spread this to anyone else. But other than that, here's where we're at. We're at 2.6 uh, graphs of rational functions. So, first of all, rational functions of fractions. So, we have a lot of things that we have talked about with these functions before where we've got to kind of carry some of that memory from previous lessons. Okay. These graphs have vertical asymptotes, horizontal asymptotes, zeros, x intercepts, y intercepts, all those different things. And we're kind of combining them into one thing. So I went through and did the homework, and I could completely understand your confusion, but we're going to go over those homework problems together and make sure you understand this. So the first thing is, what is a rational function? It's a fraction. Okay, so a fraction is nothing more than a rational function. A rational function is a fraction. So we had this first example says find the domain of a rational function. The domain, remember, when we have a fraction, I'm looking for what number will make the denominator equal to 0. Most simply said, I'm going to take this and plug it into, let's see if I can get to, there we go. I'm going to set the denominator equal to 0 and solve it. A lot of times you don't have to do the actual algebra, but if you need to, here it is. Okay, so x is equal to 2. That's the number the denominator can't equal. So when I'm asking you to find the domain of f, the domain is negative infinity to 2. 2 can't equal, and then 2 to positive infinity, because 2 would make the denominator equal to 0. Okay, they might say this, x, all x, and x can't equal 2. Okay, something like that. And then it says use limits to describe its behavior at its value. So I want to take a look at the graph here. Um, if we look at this graph of 1 over x minus 2, y equals 1 over x minus 2. Okay, so here is my asymptote at 2. Now, they have something where I'm going to go ahead and just take a quick picture of this and then go over so I can draw on it. So we had paste. There we go. So here's the graph. Okay. So what they are asking us to do for this is take a look at the asymptote. And they have some funky notation that says limit as x approaches 2, and then they put a little negative sign up here. All that's asking you, okay, of f of x equals, all that's asking you is take a look at negative 2 from the left. What's the graph doing? It's going down. So this, because it's going down, we would say negative infinity. Okay. Then they say limit as x approaches 2 to the right. That little plus sign means to the right. So what is this graph doing as we approach 2 on the right? Notice I don't point here. That's not 2 to the right. That's 2 to the left. It's never going to cross this, right? Here's my asymptote, so it's never going to cross. So we don't want to look down here. We're looking up here, and what's the graph doing? It's going to positive infinity. So there's a couple problems like that on the homework. Really, really, really simple. But understand what it's asking you. And then we have a problem that says the limit. Now, this is for when we're looking at the vertical asymptote. Okay. Now, if it asks you to look at the limit as y approaches 0, or as f of x, sorry, the limit as f of x approaches 0 from the left, okay, approaches 0. So when we're talking about the horizontal asymptote, if it's asking about this from the left, where's it going? It's going to negative infinity, and here it's going to positive infinity. You got to make sure you're paying attention to what it's asking you. There's a couple problems on the homework where I'll go over that and explain that a little bit better. So this is some really important stuff here. We've got to know how to find the intercepts of graphs, and we've got to know how to find the horizontal asymptotes. So if you recall, we had this discussion back. We had this. This was nothing more than horizontal asymptotes, right? If n is less than m, we're looking at the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then we have an asymptote at y equals 0, horizontal asymptote. Okay, so this is all horizontal asymptotes. If they're equal, we divided the leading coefficients. So for this, we divide the leading coefficients. We have this in our notes. We talked about this in chapter 1. Okay. And then if n is greater than m, and we're not going to deal with this today, we'll talk about this next class on Wednesday. But if the numerator, the denominator, or the degree of the numerator is greater than the degree of the denominator, the end behavior is a quotient polynomial function. There is no horizontal asymptote. We have what are called slant asymptotes or even quadratic asymptotes. We'll talk about that on Wednesday. The vertical asymptotes, this occurs at the real zeros of the denominator. So we're looking at the bottom of the fraction. Okay. It says, provided that the zeros are also not zeros of the numerator. Remember what happens there? If we have a 0 on top and a 0 on bottom, then that's a removable point of discontinuity. It creates a hole in the graph. I don't want to look at holes. I want vertical asymptotes. X-intercepts, where the graph crosses the x-axis. Y-intercepts are where the graph crosses the y-axis. We're simply going to use our graphing calculator or Desmos to answer those questions. So I want to look at a couple of these, kind of explain how they do these problems. Okay, so if I look at this first problem, it says describe how the graph of the given function can be obtained. So they're talking about transformations. Okay, this problem right here, 2 over x minus 3, they are calling f of x the reciprocal function, which is 1 over x. Okay, well, the way the book describes it can be a little bit confusing. If all I want to know is the vertical asymptotes and the horizontal asymptote, all I need to do is look at the problem the way it's given. Vertical asymptote would be at x equals -3. What does that mean? That means that my graph that normally looks like this, right? Normally looks like this. This is 1 over x. That has a vertical asymptote at x equals 0 because I can't plug in 0 here, and has a horizontal asymptote right here at y equals 0. Okay, so we're talking about how does it shift from this? Well, the vertical asymptote right here takes this to the left 3 units. So my new graph is going to go 1, 2, 3 right here. Okay, nothing else changes on this graph except for this 2. This 2 is my A. Well, what does A do to the graph? It stretches it or vertically compresses it, right? This 2 is going to vertically stretch this graph. So all this graph is going to do is vertical asymptote at 3 and a horizontal at y equals 0. Why is it y equals 0? Because the degree here is 0. The degree here is 1. 0 is less than 1. So I have a horizontal asymptote at y equals 0. Okay. So it says identify the horizontal and vertical asymptotes and use limits to describe the corresponding behavior. So if it asks, and there is a problem like this on the homework, if it asks for the limit as x approaches -3 from the left, well, what's it doing? Right here, -3 from the left, the graph is going down, so that would be -infinity. The limit as x approaches 3 from the right, what's it doing? 3 from the right, it's going up to +infinity. Okay, so take a look at those types of problems. We're definitely going to do a couple of those. Now the book, I'm going to erase this here, so pause it if you need to. The book talks about actually dividing here if you need to. We don't need to divide here because the way the problem's set up, but they write this as 2 f of x plus 3. Okay, this 2 being the A, and this plus 3 being my h when I have a problem that looks like this. So what they did for this example, and this is the one thing I want to make sure I show you. You guys all should be able to right now tell me the horizontal shift and the vertical shift just by looking at this graph. The vertical shift is my horizontal asymptote. I'm going to write this out a little better. Okay. Let me say this again. So horizontal shift, vertical shift. The horizontal shift, which way it travels, that's where my vertical asymptote is. How do I find the vertical asymptote? I look at the denominator. It will be at x equals 2. So this goes 2 to the right. My vertical shift, which is up and down, is my horizontal asymptote. Okay? So horizontal asymptote. What is it? The degrees are the same. So what do? I take 3 and I divide it by 1 and I get y equals 3. So my vertical asymptote is x equals 2. My horizontal asymptote is y equals 3. Okay. Now, they, to divide this, and they talk about how this graph shifts. So they actually divide this to talk about the vertical stretch and whether or not it shifts over the x-axis. Well, what does this problem say? It says x minus 2 on the outside and 3x minus 7 on the inside. We did long division, right? So they divided this. They went x, what number times x can I multiply to get 3x? Well, that would be 3. 3 times x is 3x. 3 times negative 2 is minus 6. I change the signs and I get a negative 1 here. Okay, this negative 1 is really important because that right there is my vertical stretch. Okay, so they would write this out. And again, this can be really confusing. This can be really confusing the way that they write it out. I really want you to focus on this, but I do want you to know how to find the vertical stretch or vertical stretch or compression and whether or not the graph shifts. So the way that they write this out is here's my answer, right? I got my answer of 3. So I have 3 f of x minus 2. Where did I get x minus 2? It's the denominator, okay? And then they have a I'm sorry, I should have put a minus 1. Let me rewrite this. Make sure I'm writing this out correct because this is new for me too. I've never written it out this way. I've always just looked at the graph and analyzed it um, through looking at the graph. Make that a little smaller. Make sure that this all makes sense as we're doing these problems. Okay, so as we write this, we have the division. We did 3 as my answer. Okay, and then I had a minus, and the remainder. It's 1 over x minus 2, right? That's how I wrote this. So then now I write it as a 3 minus f of x minus 2. There's my x minus 2. And again, this can be written as negative f of x minus 2 plus 3. That's my horizontal asymptote. But this is what I really want to show. This is going to show that the graph flips about the x-axis. Okay, that's negative f. It's the same thing as we had before. So I want to look at one more example like that. Just so we're all on the same page. If I ask you to compare the graph of 3x minus 1 over x plus 2. Okay, so first of all, you should be able to tell me what make sure that's not the same problem. No, it's not good. Okay, so right here, first of all, what's the vertical asymptote? I'm just going to start abbreviating this. What value makes the denominator equal to 0? X equals negative 2. What's the horizontal asymptote? Same degree, I divide. Y equals 3. So now it's going to ask you for vertical stretch, and it's going to ask you if it flips about the x-axis. So I need to do x plus 2 on the outside and a 3x minus 1 on the inside. Okay, so what number times x equals 3x. That'd be 3. 3 times x is 3x. 3 times 2 is plus 6. I'm going to change the signs. It gives me a negative 7. There's nothing left that I can do with this. So if I write my answer out, it's 3 minus 7 over x plus 2. Right? This is how I write my remainder. Well, what they want you to do is to be able to write this in terms letting f of x equal 1 over x. So we have 3 minus 7 times f of x plus 2. All I do is take the numerator of the remainder and put it in front of f. Okay. And then you'll see it written like this, negative 7f of x plus 2 plus 3. They just move the 3 to the other side. This is my vertical shift. This is my horizontal shift, which I got right at the very beginning by looking at these, knowing my rules of vertical asymptotes and horizontal asymptotes. This is the important thing of why you have to divide, because my remainder is going to tell me that, hey, this graph is going to be vertically stretched by 7, and this negative flips it about the x-axis. Okay, so I wanted to show a couple of those problems, and then I just want to go over a few of your homework problems together, and then I'm going to reassign an assignment that has the same exact types of problems. Hopefully the numbers change a little bit, so that we can look at these, but I want to go over the homework with you. So this video kind of gives you a rundown of, again, how to find the vertical asymptotes and how to find the horizontal asymptotes. To find vertical asymptotes, we set the denominator equal to 0. Horizontal asymptotes, we go ahead and do this. I'm going to talk about this as we go through the homework. Where did you go? Where'd you go? I got to stop the video. There we go.